Hey class, Mrs. Anderson here. This will be 5.2a, writing equations of polynomial functions. Both the kids are napping, so cross your fingers that that stays that way for a little bit here and that the bedtime music in the background doesn't distract you too much while I go through this lesson. So first, just a review of the fundamental theorem of algebra says that if a polynomial of degree n, then the polynomial has n roots. So our first one is a degree of 3, a cubic function, so it has 3 roots. The second example is a quartic polynomial, degree of 4, so it would have 4 roots. And then remember or learn now that imaginary roots always come in pairs because they have the imaginaries are called the complex conjugates. So if you have an imaginary answer, you always have a pair of imaginary answers. So if you have 2 plus 3i is the solution, then 2 minus 3i is also a solution. Get in bed, Mia, now. If 5i is a solution, then negative 5i has to be the other solution. So they always come in pairs. That'd be like if x squared equals negative 25. So then you get plus or minus 5i. You always get 2 answers with the imaginary. Identify the factors of the polynomial given these zeros. So the factors, this is like what the x equals. So if x equals, we'll call it k, then x minus k is a factor. So if these are our answers, x equals 7, 3, and negative 4, that means that in factored form, the polynomial would have looked like this. X minus 7, x minus 3, and then to get negative 4, it would have been x plus 4. So those would have been my factors of the polynomial if I would have solved for x and got those answers. Here, if it would have been 2, it would have been x minus 2, and then x minus 3i and x plus 3i, which really means my factors, if I would have got 3i and negative 3i, it really would have been x squared plus 9 would have been my factor. Because x squared plus 9 equals 0, then x squared equals negative 9, and x would equal plus or minus 3i. So kind of thinking backwards, if you know the answers, what would the factors be? So for this one, if you got the answers of 8, 3 minus i, and 3 plus i, then your factors, your first one would be x minus 8, and then you'd have x minus 3 minus i, and x plus 3 plus i. Or wait, be x minus 3 minus i and x minus 3 plus i. Sorry, minus all the time, x minus k. Now, this one is a little bit more complicated to think about than the x squared plus 9 factor, but if you were to multiply this out quick, you would see a pattern with these as well. X squared minus 3x plus ix, and then negative 3 times x, negative 3x, negative 3 times negative 3 would be plus 9, and negative 3 times I would be negative 3i, and then multiplying the I, negative I times x would be negative ix, negative I times negative 3 would be positive 3i, and then negative I and positive I would be negative I squared. Now, a few of these things are going to cancel. We're going to have a positive ix and a negative ix is going to equal 0. And then a negative 3i and a positive 3i equals 0. And I squared is negative 1. So here we have a negative, negative 1. So it's going to be plus 1 at the end. So then combining our like terms, we'd have x squared. Then negative 3x is negative 6x. And then 9 plus 1 is 10. And then it'd be x minus 8. So that'd be the factors there. Here we'd have x minus 5, x plus 3, And then if you got the answers 2i and negative 2i, you would have had an x squared plus 4 to get the 2i and negative 2i as a factor. Uh-oh, the baby woke up. Hopefully I can finish this quick before she starts screaming. So to write a polynomial in factored form means to write it like this. If I added the y equals and then write the factors. And so the leading coefficient goes out front, the a, and then it's x minus the root. So if my leading coefficient is 1 and I have the following answers of 1, negative 4, and 5, my polynomial function would be f of x equals leading coefficient of 1. If 1 is an answer, then x minus 1 was a root. Negative 4 is a solution, then x plus 4 was a root. And 5 was a solution, then x minus 5 would be a factor. Ava. Okay, let's do another one. This is a polynomial function of least degree that has real coefficients, a leading coefficient of 1, and these as our factors. So we got f of x equals a leading coefficient of 1, and then we have 1 as a solution, so x minus 1 is a factor, and then negative 2 plus I would be x minus negative 2 would be plus 2 plus I, and then x minus negative 2 again would be plus 2 minus I. So when I plugged in these factors, I got x minus negative 2 minus I. So that was where I got that plus for both of those. Now, in order to get real coefficients, you do have to multiply this out. A box might be a good option here because you can keep your work more organized. So if you did like x, 2, and I, and then x, 2, and negative I, you can multiply it out. You get x squared, 2x, negative ix, 2x, 4, negative 2i, ix, 2i, and negative I squared. Then you'll see that you'll get those opposites like 2i and negative I. Anything that's imaginary should cancel. And then negative I squared is going to be positive 1 since I squared equals negative 1. So combining my like terms, I'm going to have an x squared, a 2x and a 2x is going to be 4x. And then I have a 4 plus the 1 is plus 5. And then I still have that times the x minus 1. So at this point, I've at least satisfied the polynomial of least degree that has real coefficients and a leading coefficient of 1. So I got rid of my imaginary coefficients. And lowest degree means that I didn't add any extra x values in. It would be a degree of 3 because you would multiply this out one more time and be x, and x squared would be x cubed. So that's what it means by lowest degree. Okay, this one, I want it in standard form. Standard form is, like standard form of quadratic is ax squared plus bx plus c. Cubic would be ax cubed plus bx squared plus cx plus d, and etc. So start with factored form. So y equals leading coefficient of 1. The zeros are x equals 2, so you have x minus 2. We got 3, so x minus 3. And negative 3i. And if I have a negative 3i, since they always come in pairs, if I have negative 3i means I always have a positive 3i too. So I'm going to have x minus 3i and x plus 3i because I'm going to have x minus negative 3i and x minus 3i, so one of each. Now I'm going to multiply these out. I know that these are complex conjugates, so this will multiply back to x squared plus 9 because if you were to solve x squared plus 9, you'd get plus or minus 3i. multiplying this out, distributing it, I'd get x squared minus 3x minus 2x plus 6. I'm going to combine like terms here, x squared minus 5x plus 6, and then x squared plus 9, and then multiply that out, and you can use a distributive property again, or use the box method to help keep your work organized. Take x squared minus 5x times 6 and x squared and 9. So be x squared and x squared is x to the 4th. X squared times negative 5x is negative 5x cubed. X squared times 6 is 6x squared. 9 times x squared is 9x squared. 9 times negative 5 is negative 45x. And 9 times 6 is 54. Okay, let's just double check my work quick. And then combine like terms. So I'd be y equals, well, I still have the leading coefficient of 1. But if I multiplied everything by 1, it wouldn't change my answer. So this is going to be my final answer, leading coefficient of 1. Then I just have 1x cubed term, so minus 5x cubed. I have 2x squared terms, be 15x squared. And then 1x and plus 54. So that would be the answer there. All right, I don't know if you can hear my baby crying in the background, but I'm going to set up this one at least. Polynomial function, we want in standard form again. Least degree leading coefficient of 1. So y equals 1, x 4i is a solution. That means that you have both roots. So if you have a positive 4i, you have an x minus 4i and an x plus 4i. They always come in pairs. And then this one, it comes in pairs too. So I'm going to have the x minus 3i and the x plus 3i. These ones are conjugates, so they're easy to multiply back out. I know that this is going to be x squared plus 16. And I know that this one will be x squared plus 9. Because if I were to solve those, I would get 4i and negative 4i and 3i and negative 3i. So if you multiply those out, that's what you would get. And then multiplying those out to get your final answer, you get x to the 4th, x squared times 9 would be 9x squared. Then 16 times x squared would be 16x squared. And 16 times 9 would be 54. And 14, 144. And then leading coefficient of 1, but everything times 1 would just be the same, like it wouldn't change it. 1 times that, so x to the 4th plus 9x squared plus 16x, oops. I can combine like terms here. 9 plus 16 is 25x squared plus 144. Final answer. The baby crying is distracting me. Okay, I better go get her. Thanks for watching, guys. Hopefully I can get the rest of the videos for this week done today.